Hello everyone, this is Simple Math for you. We are going in this session to continue the revision for the end of year and revise some practice using some practice questions. We are going to start by lesson 13.1, which is reflection. Reflection means mirror image, mean flipping. And usually they give you in the formula sheet some formulas regarding reflection about x-axis, y-axis, and y equals to x. So starting with question 48, find the image of point 0, 1 and the reflection in the y-axis. Referring to the formula sheet, across y-axis, xy turns to negative x and y. Only change the sign of the x coordinate. And since the x coordinate here is 0, so the point will stay the same. 0, 1 will stay the same because you are not going to change the sign of the 0. So that means the reflection will be the same point, which is 0 and 1. And actually, it's repeated here. You can choose either B or C. It's the same here, but by mistake, it's repeated. 49, find the image of point A, 50, and the reflection in the x-axis. And the reflection of x-axis, xy, turns to x and negative y. Means what? X and negative y means changing. This is x-axis, right? X-axis, x and negative 1. So it means we are changing only the sign of the y. Okay, y is 0. Also, we are not going to change the sign. So we will leave this as it is, 50. Find the image of point A, 1, under the reflection of y equals to x. Under y equals to x, xy turns to y and x, means just exchange x and y together. So x becomes y and y becomes x. So actually when you exchange them, it will be the same. So if you take another point, let's say, for example, if it was -1 and 3, it turns to 3 and -1, to be clear. For this point, let's go and assume another point rather than the 0. Let's assume that the point was -3 and 6. And the reflection of y-axis, what will happen? As you see, only we are going to change the sign of x. So this will be 3 and 6. But if you take -3 and 6 and reflect it across x-axis, you will leave the x coordinate the same and you will change the sign of the y. So it turns to -3 and -6. This is another extra example just to explain what happens because 0 did not show actually what changes we have done. Now we have here, find the image of the point 0, 1 and the reflection of x equals to 1. Okay, let's have an idea here what is happening here. I will sketch it just to show you how can I get a formula or get a way to do that. X equals to 1 is this one. It's a vertical line passing through the 1. This is x equals to 1. 0, 1 is this one. 0, 1 is go to 0 up to 1 is this one. This is the point 0, 1. So what will happen if you reflect this point? If you reflect this point means you are counting 1 unit here to the line of reflection, and you are going to count 1 point to the other side of the line of reflection. So we will reach here. This point is how much? It's 2 and 1. So if you sketch it, you will get the answer actually. So you will get the answer, which is 2 and 1. But is there any formula or anything guiding us? We can do it this way. Now, what is happening here? Under x equals to 1, under reflection about vertical line. So what is changing is x only. X only will change. Y will stay the same. So I will leave the y. So x is the moving. This is the changing. What is the change? You can see from 0 to 1, you added 1. So you add another 1. So you reach 2. This is easily can be done. Okay, let's try with y. Okay, give an example with y equals to 2 or y whatever anything else. I will remove this just to have a space. If you have, for example, reflection across y equals to 2, point anything, point 2 and 3. Now, what will change? Y will change. So that means 2 remains the same and y will change. How much y will change? Now, you will see what happened from 3 to 2. It's decreased by 1. So you will decrease another one. It will be 1. Another way to do that is just multiply this by 2 and subtract the original y, which is 3. So 4 minus 3, which is 1. So multiply any factor, any number, سواء x or y, and subtract the original one. If it was x equals something, subtract the original x. If it was y equals something, so subtract the original y. So this is how we do it. You can sketch as well, but without it, it's fine. Now, 0.2 and -3 is reflected in the x-axis. Find the coordinates of its image A prime. Reflection x-axis, as we mentioned, xy turns to x and -y. That means who is changing? Y only reverses the sign. So that means this one will be positive, and that means the result will be A. A prime will be this one. When M4 minus 9 is reflected in the y-axis, it's located at y-axis. So xy going to, you can write the formula in front of your eyes so that you don't forget. So what is happening now? Only the sign of the x coordinate will flip. So you will have -4, keeping the y the same. Now, reflection across y equals 2. Y equals 2 means x stays the same. X stays the same. And we will see from -6 to -2, you have added 4. So add 4 here. So it will be 2. Or you can use the formula I have told you about. Multiply this by 2. 2 times -2 is -4. Then subtract the original y. So it is -4 minus original y is -6. So it will be 2. In all cases, you will have the same result. Here we have reflection of 0.4 minus 1 across y equals to 3. Y equals to 3 means L prime will have the same x. What happened from -1 to 3? You are adding 4. So you add 4 here. So it will be 7. But he is not asking you about the point. He wants only the x coordinate. So no need to do all that. It's just I'm doing a practice for you. X coordinate will stay the same. So x equals to 4. No need to do anything. When the point xy is reflected across y equals to x, according to the formula, y equals to x, it will be flipped. It will be yx only. That's all about reflection, and it's easy to know. Now, translation. Translation means sliding. You are sliding something, keeping all the distances, keeping all the dimensions the same. You are not changing the dimension. You are just moving the object left, right, up, and down. So the movement will be either horizontally or vertically. So the vector that translates this to that is what? You can do it mentally, but since it's fraction, I prefer to do it in this way. The new minus the old. So for the x, you will do 2.1 minus the old. And you can find it using the calculator. 2.1 plus and minus 3.8, it will be 5.9. And same for the y. Do it for the same for the y. Minus 4.3 minus 7.5. So negative 4.3 minus 7.5, it is negative 11.8. Negative 11.8. Determine whether the translation maps triangle JKL to J prime, K prime, L prime. So this is the image. This is the new one. So what will we do? What is the vector? The vector is the amount, the number of units that have been moved. And you have to write it in the order of horizontal movement, then the vertical movement. If the horizontal movement was to the right, then it is positive, to the left, negative. For the vertical, up, positive, and down, negative. Remember that you start by the pre-image. So from here to here, you can count 1, 2, 3, 4, 5 to the right. So 5 right. And 1, 2, 3 up. So 3 up. How can we know if there is a translation? If all the points have been moved equally, then a translation happened. So if you check for K, it's the same number of units. If you check for L, it's the same number of units. So that means, yes, there is a translation. So we'll answer yes, but you have to write in order. 5 units right, so it is positive 5. Then 3 units up is 3 up. So this is the answer. Write down the translation vector that maps triangle A, B, C. So now this is the old one. It is moving to that direction. So we have this direction, this way until the B prime, and this way. Now, since this unit express scale of 2, you have to be careful. Now, if you count, be careful. You have half here, and then 1, 2, 3, 4, and another half. So 5 units, each by 2. So it is 10 units to the left. So this will be negative 10. Down, if you count down, I will use another color to be careful. This to that, it has been moved 2 units down. 2 units down by scale of 2, so it is negative 4. If you are afraid to have mistakes, then you can find the difference between 8 and minus 2. يعني from 8 to minus 2, what will happen? New minus old. So for the x, the new minus 2 minus the old, which is 8, so it is minus 10. Let's say we are finding the y. For the y, the new is minus 5, minus the old is minus 1. So minus 1, 5 plus 1 is minus 4. So we have the same result, the same vector. The graph of ITR and the image I prime, T prime, R prime are shown below. Find the translation vector. Same technique. Here you have moved from I to I prime. From here to here, 1, 2, 3, 4, 5, 6 to the right. So it will be positive 6. Then down 1, 2, 3, 4. So it is negative 4. Of course, here the scale is 1, 1, so no need to worry about it. So you will choose 6 and negative 4, which is, in our case, D. Let's change the color. Find the image of Q, which is 4, 7 after translation along, this is a vector, 1, 3. So what will happen? 4 and 7 have been moved across this vector. Simply just add the x's with the x's and the y's with the y's, because the 4 will move 1 unit to the right. So just add 4 plus 1, 5. 7 plus 3, 10. This is the new point, simply. And if it's negative, just add the negative number. No worries about it. The image of A, which is minus 2 and minus 3, under the translation is A prime. So A was minus 2 and minus 3. It becomes A prime, which is 7 and 4. They want B, which is 3 and negative 1, to calculate B prime. So we will first find the vector that translates A to A prime. Yani how much this A moved to A prime? Either you do it mentally or you can subtract to find the vector. If you have the vector, you will add. If you don't have it, you will subtract. So 7 minus minus 2, 9. 4 minus the minus 3, which is 7. That means the point has been moved across the vector 9, 7. So we will apply the same vector here. And after adding, now the vector is here. So you will add now. Here in that procedure, we will subtract. But here we have everything, so we will add. If you add 3 plus 9, it's 12, minus 1 plus 7, which is 6. So our B prime will be 12 and 6. Find the coordinates of the image of the triangle after translation across -2 and -9. Okay, so we will start by classifying the coordinates that we have. So originally we have M is -3 and 7. We will apply the vector. So M prime will be adding -3 plus -2 is -5. 7 plus -2 is -2. -9, I mean -2. Then we have P. P originally is 2 and 6. Across this vector, it becomes P prime. Add 2 plus -2, 0. 6 plus -3 is -3. Then N is 0 and 4. Vector -2 and -9. So N prime, 0 plus -2, -2. 4 plus -9 is -5. If you are asked to plot, then read the question carefully, or graph, you need to graph. So let's see, -5, -2, just in case you are asked to do that. So this is -6 because the scale is 2. -5 will be the middle, with -2 is somewhere here. So this is M prime. 0 and -3 would be somewhere here. -2 and -5 will be somewhere here. And if you match, this is N prime. You will see that this triangle has been translated. Find the image of K, L, and J after translation along vector 2 and 3. So we will take one of the points, for example, 1 and -1. Moving it across vector 2 and 3, add 1 plus 2, 3. So K prime is 3. -1 plus 3 is 2. The only choice with this K prime is this one, so no need to check the rest. Done. Moving to the rotation. Rotation means turning the object. دوران. Match the below. The transparencies, طبعا, you can pick them from the formula sheet. You are not going to actually to memorize everything. So here we have some choices, as you see here. The transformation xy to -x -y is A, is 180 degrees about the origin. So you will choose A. The transformation xy to y and -x is 270 degrees, which is in our case B, this one. Last one, transformation -yx becomes -1x, it's C, this is 90 degrees. These are counterclockwise and about the origin. Yeah, so the formula sheet will give you that, so but just it's easy to pick them. Given the triangle below, answer the question. Find the images of AB after rotating 180 degrees. So let's see. A was 4 and 5. 180 degrees states that xy will go to -x and -y. So without flipping anything, replacing x and y, just flip the signs of both. So this will turn to A prime, -4 and -5. B was 2 and 1. He's asking about that one. So according to this formula, just flip the signs. find the image, because he's asking about the origin. So no need to do anything. No need to add vectors or take it away or move it. Directly apply the formula. Now, we want the same points to be rotated about 90 degrees. Our rotation 90 degrees about the origin. So if A was 4 and 5, then A prime after 90 degrees, it becomes minus y and x. xy turns to minus y. What happens here? They are flipping x and y, they are exchanging them, and then flip the sign of the first coordinate. So first, I will flip those, so it will be 5 and 4, and then I'll change the sign of the first one. Now let's see B. B was 2 and 1. So I will first flip the locations, then flip the sign of the first coordinate. This is how we deal with that. Find the image of AB, same points after 270 degrees. A was 4 and 5, and let's check. 270 degrees, xy turns to y and minus x. So we will exchange x and y and then flip the sign of the y coordinate, the new y coordinate. So what will we do? A prime, we will flip the locations first, and then flip the sign of the new y. E was 2 and 1. So B prime is exchange them, then flip the sign of the second coordinate or the y coordinate. That's it. The questions of rotation are easy. No need to actually to go through the details for this revision. For further details, if you want to come back to the original rotation lesson, if you want to rotate about a point, not the origin, you can refer to lesson 12, actually it's 13.3 in the module number 13 in the YouTube channel. But in this revision sheet, we don't need that. Symmetry. Okay, tell whether each letter has line symmetry. Place X in the appropriate column. Line symmetry means the line that can cut the shape into two congruent parts so that one part or one side is a reflection of the other, exactly the same as the other one. So let's check. Does A has line of symmetry? Yes, you can cut A vertically like this, so we'll put X here. S have? No, doesn't have. And Z doesn't have. You cannot notice that. M, yes, have, because you can cut it this way. So you can cut M at the middle, and this part is exactly the same as that part. H, yes, it has. Even H, it have two, one here and one there, actually. So yes, it has two lines of symmetry. N does not have. And D has this way. So it is here. So yeah, we can draw lines of symmetry. A rectangle has how many lines of symmetry? This is the rectangle, والمستطيل يعني. This is the rectangle. If you draw a rectangle, and I draw it this a bit slanted, I will do it like this. This is rectangle. Actually, if you notice that the vertical line at the middle cuts at the rectangle into two congruent parts, and also the horizontal line cuts it into two congruent parts. So in this case, we have two lines of symmetry. This is not line of symmetry. If you fold the rectangle about this diagonal, it will not be over it. Match each description to its correct image. Let's see this question now. We have different shapes, and we want to check how many lines of symmetry does each one having. The first one, as you see, it can have 3 lines of symmetry. You can cut this into one from here, one from there, from this side. So it has 3 lines of symmetry. So we are going to choose B. The second one has 2 lines of symmetry only. We can cut it from here and cut it from here to be congruent to each other. C is here because it has 4 lines of symmetry. 1, 2, 3, and this is the fourth lines of symmetry, 4 lines of symmetry. Finally, this has 6 lines of symmetry, which is D. So this is 1, and this is 2, and this is 3, and this is 4, 5, 4, I mean. And you can also have 5, 6. So you can draw as much as you can lines of symmetry. Now we have rotational symmetry. Rotational symmetry means you can rotate the shape or turn the shape, and the shape comes to the original position or looks like the original shape. So let's check this figure. This figure, as you see, if you rotate it to counterclockwise or clockwise, no worries. 3 times before, three times before the full rotation or until the full rotation, it will come back to the original position. So that means here we can say that the order is 3. Order means number of times that the shape can rotate and comes back to the original position, the original shape. So because if you rotate this here, for example, this 1, 2, 3. If 2 becomes instead of 1, you will not notice that the shape has been changed. So this is 1, and another time is here, and the third time when it comes back after 360 degrees. So we will say that the order is 3. But the magnitude refers to the angle. Magnitude is 360 divided by the order. So it is 360 divided by 3, which is 120 degrees that we can see here. So here is asking you how can you find the order of symmetry. If the order of symmetry is x, what is the magnitude? So the magnitude is 360 divided by x. Determine whether the below figure has rotational symmetry. Yes, it has rotational symmetry. Here, if you rotate this flower, it comes back to the original or to exactly same as original shape 8 times. So here, the order is 8. We have 2 options here with yes and order is 8. The difference will be the magnitude, which is the angle. So the magnitude will be 360 divided by 8, which is 72 degrees, I guess. No, 45, sorry. 45. It is the magnitude, which is now option A. Determine whether the below figure has rotational symmetry. Yes, also, yes, it has. You can rotate this how many times? 1, 2, 3, 4, 5. 5 times. So the order here is 5. And our magnitude will be 360 divided by 5, which is 72 degrees. That means every 72 degrees, the shape comes back to exactly same shape. Here, every 45 degrees, and it's very clear here, by the way, every 45 degrees, it comes back to the original position. Now here, every 120 degrees, it comes back to same as the original shape. This is the meaning of rotational symmetry. Now, I'll stop here. Last part, I will talk about angle relationship and congruent triangles, inshallah, in the last part of this revision, which is module 14. Thank you for watching. ونراكم إلى اللقاء. Thank you.